So yeah, I already briefly introduced myself. So I'm a founder and a CTO of Tier4, which is a startup based in Japan. I'm also a founder and a chairman of Autoware Foundation, which is a non-profit organization of open source community, which drives R&D of Autoware, which is the open source startup project. And my main affiliation is an associate professor at the University of Tokyo. So the history of autonomous vehicle is quite long. And as far as I can see, back in 1980s, the CMU had a autonomous truck project. And I remember that they made a highway project from Pittsburgh to somewhere in California in 1995. But those projects, it's more how to say, the computing performance or data processing capability was quite limited, while the one we saw in 2007-9, which is the basis of what we're doing today. So one showcased by CMU, and later on that project turns into Google autonomous driving project. So we followed this line of work, and in 2015 we started open source project and our startup. So when I started open source project, the open source actually belonged to my startup. But I realized that we're getting more and more users and applications, and I thought that one open source project belonging to some particular company is not a true open source. So I decided to hand over ownership of open source to an NPO of my startup. So that is Autoware Foundation. Now, open source software, it's called Oldware, is completely governed by this Autoware Foundation. And UPenn, the professor Raful, he is also the member of Autoware Foundation as F110 organization. So Autoware is, I would say, it is a collection of components of autonomous vehicles. So if you download Autoware, you can make it installed into your vehicle if you have the vehicle sensors and computers. This is open source, so some of kind of research activities, of course, they are reflected into the project, but you can see each component of Autoware, it's solid, but it's quite traditional. So you can see some, say for instance, perception, localization, control algorithms, which are quite well known in the literature, but they are not, say, way advanced. We always, of course, trace the state of the art, that presented in the conference, but we often have, say, 1 year or 2 years gap when new algorithms emerge. But it takes a while to get them into Autoware because we have to verify and validate kind of design and implementation of algorithms as part of the system. But yeah, all in all, when you download Oldware, you have everything. You have everything required to drive autonomous vehicle, which I will introduce today. So we, as a startup in Japan, use AutoAware to commercialize AD solutions. So we started kind of operation of robotaxis in Japan. You can see that we can already remove human drivers from the car. It also happens in the US, some Asian countries. If you apply for the government, and if you qualified, even on the public road, now you can operate taxis even without human drivers. I see that Google is actually quite doing this quite well. They have a wide area of operation in, say, Nevada or Phoenix, but on the other hand, we are more focused on city-wise environment. So this was actually the first customer. He is the government prime minister of Tokyo City, and we went off the very central of Tokyo. Our kind of loud an area in Tokyo qualified for the operation, still very limited. It's just between 1 mile to 2 miles with a fixed route, but still it's quite a big step towards implementation of real services, as we can now drive this taxi without any human driver in the center of Tokyo. And if we can set a safety driver inside the car, we can actually do such field test in many places. So I wouldn't say this is 100% complete. So sometimes this safety driver has to take over the control of the vehicle when the vehicle fails to, say, recognize the objects, or say when avoiding some obstacle, or sometimes the route decided maybe not appropriate, so the safety driver can still take over the control. But this is what we can do the most. I say that this is amazing since everything is built on top of open source and real environment, and Tokyo would be one of the most complicated cities in the world. So now you can see the vehicle just operate by themselves, although we still have the safety driver. Now this open source software started being deployed in other services. Say the Tokyo Olympics, the shuttle bus built by Toyota, it was actually 100% powered by Autoware, and recently Honghai, a Foxconn, quite well known as iPhone manufacturer, they started EV open platform, and this platform also adopts Autoware as a baseline software platform. we're gonna make a big announcement in October with Foxconn. So if some of you found that news, then yeah, you can remember that it was the presentation mentioned about that. So Autoware, it's interesting to say that from my point of view, not only Autoware, but also all other autonomous driving software, basically the architecture, they look the same. No, no super original, ideas would be necessary. So we already know that from the long history of autonomous vehicle research and development, the architecture of autonomous driving, it's almost a common sense. So you have perception, planning, control. They are based on the localization, which in turn needs sensing, maps, and interfaces. So nothing special, but what is special is how, say, you can train the perception. So you need a data set which is differentiating your capability. So the architecture may not be a well, it's a tanky solution if you have an architecture, but it's not really differentiate your value. So what can differentiate your value is the data set, or say parameter tuning, and the designing operational building operation design domain, which also I also introduce later. So, but all in all, the architecture must be solid. It doesn't have to be original, but it has to be solid. So sensing and localization. So Autoware supports today the LiDAR, GNSS, and IMU. So we also have a camera or radar, but we don't use them for the localization. So, and localization is based on point cloud data. So we need a map information to find your position inside that map. And twist means that your direction in 6 axes. So you have sensors and map data, then you get your position, including your direction in 6 axes. So X, Y, Z, and low your things. So we also use GNSS or GPS to say support the collection of the result that comes from LiDAR and the map. But GNSS is more a complementary sensor used in Autoware, while LiDAR and the map are main components for the localization. We also use extended Kalman filter to also complement the result of localization. So NDT stands for a normal distribution transform, which is a scan matching algorithm, very well known. But the LiDAR frame rate is quite limited. Today it's 10 or 20 hertz. So every 100 milliseconds or 20 or 50 milliseconds, you have a blind time frame. So you can use a Kalman filter to support this gap between the frames. And pose and a twist, as I said, is a your position and direction, and we also have as I said, EKF feedback to support the gap between frames, or you can say delay caused by many reasons. And traffic light recognition is one of, from my point of view, one of the most difficult work in autonomous vehicle if you try to address just by using the camera, because you can see the picture here, and if you only have the camera, you need to find first which area of interest includes the camera, the traffic signal. Then you have to recognize the color of the light. So to ease this work, we can also use the map, because the map knows. So the map is 3D. It's not a 2D GPS map. It's a 3D high definition map. So the map knows exactly what position in the camera or from the vehicle position the traffic light, traffic signal is located, if the localization is correct. So here we have a strong assumption that the localization is very accurate, so that we can use the information of the map to focus on the area of interest that should include the traffic light. So we don't have to search for the entire picture. We can just check the area of interest told by the map information. So we can focus on, in this case, for example, just the yellow box, then find the traffic signal, which reduces false positive, because we know that other areas of interest in the picture do not include any traffic signal, so we don't have to search for those areas outside of this yellow box. Now, the color recognition is hybrid. We use both quite classical color filtering or convolutional neural net. And in my experience, convolutional neural net doesn't have to be deep, in depth. We can use the lightweight network to recognize the colors. Oh yeah, I already explained this. So so we can use the map information to filter out the area of interest that are not related to traffic signal, so which can reduce the the false positive a lot. And color estimation or prediction, as I said, we quite encourage Oldware users to use convolutional neural net rather than the color filtering. So, but the CNN is not to depth, so it's quite lightweight. You don't have to worry about the computation power today. So planning it is one of the work in progress in Autoware. So it contains quite basic set of lane driving. So we need a lane information from the map, and it supports, of course, lane change and obstacle stop and avoidance. But I believe that in order to get behavior of the drive, close to the human behavior, I think the planning module needs a huge improvement. But today, it's still acceptable for real services, as the most of the AD services today not required to behave as a human. It is quite acceptable if it can change the lane, avoid an obstacle, and stop the vehicle safely. So for that, to that end, the planning module of Oldware is acceptable. But from research point of view or cutting edge point of view, it needs a huge improvement. For some reason, it includes Japanese, but the control, it's nothing special. So we use a very traditional lane follow or path follow algorithm, and also we use a model predictive control to make it robust against external or environmental errors. So the control algorithms implemented in Autoware, I think it can be a very good reference for even for the researcher who wants to use it in academia. So the control mainly falls into two classes. So one, pure positive, it's a traditional path follow. It only kind of calculate the steering how long to go there. So it always try to say drive the car along the circle. So it can it sometimes may not be able to precisely follow the path, as it's always set the steering angle to go there some point. While MPC is it doesn't use a particular, say, target point. So it tries always decide steering angle to precisely follow the path. I think there are pros and cons in both algorithms. So pure positive is very lightweight. It doesn't really consume computing resource, but sometimes you may not be able to follow the path. But sometimes even human drivers do not follow the path precisely. So pure positive, you sometimes feel more the result of the control is more close to a human drivers, while MPC is always try to precisely follow the path. So sometimes it requires computing resource much more than pure positive, and the way it drives may also be a bit different from human drivers. As I said, human drivers always do not always follow the path, while MPC by this design it tries to follow the path. So now let's move on to the introduction of my startup. Autoware is open source, and ownership of Autoware belongs to Autoware Foundation. So what my startup is doing. So my startup now, I it's quite difficult to count the number of people, employees, as there are so many students also involved. So for employees or permanent employees, I think we have somewhere between 200 to 250, but including student employees, I think we are now getting close to 400. So if you're interested in open source development, you all kind of welcome to work with us. It's quite fun. So in 2015, actually it was my private project. So I saw Google used Prius, Toyota Prius in 2009. So I also did the same kind of modification with my friend and make it by wire manually. I mean, we made a hack to the vehicle. Then we connected the computer, then installed very first version of Autoware. And in 2015, it actually works quite well. So I decided to make it a business. Now, TU4's business is to provide a full stack solution to develop or operate autonomous driving system based on Autoware. So you can imagine that Oldware is Linux and Tier 4 is say Red Hat, Ubuntu. So we are like a distributor of Autoware, but Linux is just a software. But Autoware is it's a autonomous driving system. So some in most cases Tier 4 needs to understand hardware like sensors or computing capabilities and a lot of automotive information such as safety features. But the relationship between Tier 4 and Autoware may be similar to Linux distributors and Linux. And Robotex is one of our tech symbol, or maybe Robotex is the tech symbol of all other kind of AD companies. It may be still a long way to go, but as a tech symbol, TU4 is very interested in a robotaxi project. And TU4's product is kind of reference design or reference autonomous driving kit based on Oldware. So we call it Pilot.auto, which is TU4's product, is a combination of hardware and verification validation with Oldware. So Oldware is open source, it's free. But hardware or how to verify or validate the system needs large amount of experience and know-how. So that's what we said for our customers. Just an example of how we build the system based on Autoware. So most of the customers ask Tier 4 to choose sensors, as there are so many sensors today. Even LiDAR, I can tell there are 20 or 30 LiDAR makers. Each of them has a different feature. So we listen to the customers and understand their specification or requirement, and based on their specification or requirement, we derive the best configuration of sensors. And we have the simulator to check to say in case of the LiDAR, we have to guarantee that there is no a dead angle, and even the dead angle we have to define operational design domain. When something could be present within the dead angle, then we have to stop the car. So that's how we can ensure the safety, which I can explain a bit detail later. And just for your information, so how we build the system. So the camera is the most well recognized sensor, but it only detects the object on the two-dimensional image. So we prefer a LiDAR which is which can scan the environment. So having a LiDAR and a camera, then we call it the sensor fusion to produce more rich information. So the LiDAR scan can tell you distance information around your ego vehicle, while the camera tells you color information or more high resolution information. And 3D map is also very helpful to enhance the information, as if you know which lanes you are driving, so maybe you can focus on the objects that are located in the same lane as your vehicle. So you can somewhat ignore the objects kind of outside of the lanes. It really depends case by case. Sometimes you have to take care of the pedestrian even outside of the map. But the map information is really helpful, like left hand, right hand, sometimes very complicated scenes. But the introduction of high definition map information can basically help you to ease the problem even in the complicated scenarios. So and object detection often based on deep neural net. And in addition to object detection, you also have to use, say, camera filter or even deep learning to predict the future path of the detected object. So in this case, the object detected right in front of your ego vehicle, it doesn't have any velocity information. So that means this car by high probability is not moving. So you may want to stop. While if the detected vehicle just in front of yourself has the velocity information, that means that detected car is moving. So you may follow, so you don't have to stop. So the path prediction is likewise, very important to make kind of planning decision. And I don't know how comfortable this video is showing in your end, but so the Autoware modules include perception, planning, control, and localization. So everything is running in real time and using 3D map information. The visualization of the results of the computation done by Autoware looks like this. So you compute your vehicle position very precisely. It's a few centimeters accuracy, and the map information, so exactly which lane you are driving, and the objects around yourself are also precisely detected by using deep neural net, and the prediction on their behavior is also predicted. So And traffic light signal also with the support from the map information is also recognized. And the planning also includes the lane change. So again, what is amazing here is everything is built on top of open source. And in the last minutes, so I can briefly introduce a another tier 4's product, which is a web tool chain to support the development or operation of autonomous vehicle designed based on Autoware. So it's a cloud and edge system. It's a microservice architecture supporting, how to say, kind of authorization, as we don't want kind of random vehicles to access our cloud system. So we have accounting system which can authorize the client vehicle, and we entirely provide a, say, map API, fleet management API, remote monitoring API, all of which are major requirements in order to get the vehicle qualified to operate on a public road. So this is one of demo video to support kind of development of autonomous vehicles. So you want to train your deep neural net. So you want the data set. We provide a huge data set, and this web tool chain can allow you to search for the target scene. Like you can find, say, the camera data in nighttime and includes traffic lights. Then you can easily get access to that. And to verify and validate the behavior of Autoware, so you can actually create your scenario. So when you talk to the customer wants to know if the expected scenarios are already tested or not. So using our tools, we can create test cases. So it's just a simple example. So you have Eagle vehicle driving and approaching another preceding vehicle on the same lane, and you can set kind of target velocity and simple set of behaviors, and it's all based on YAML XML format. Then you can register this scenario format onto our cloud system. Then every time you build your Autoware system on the GitHub, this test scenario, you can see if it's passed or not. And results of the test, you can check on the dashboard. Say you can find that which test succeeded or not, and you can also tell the scenarios succeeded, how it actually tested. So in this example, this test case, it was right hand on the intersection, and there are 5-6 objects, and it detects the objects approaching from opposite lanes, high velocity, low velocity, and even some pedestrian is in Zebra. And it approaches, it predicted, and it stops. Then once it's clear, it goes. So this case, the test is passed. So you can always check this test every time you build your Autoware system on the GitHub. Other than that, yeah, so it was scenario-based test, while this is more random test. So we use Unity or Unreal Engine and create a virtual world, then just let the vehicle drive in the virtual world. No specific scenarios. It's always sometimes other objects can appear suddenly, and we can only see if it fails. Say if it hits some obstacle, then we can check in what case the vehicle fails to recognize. But as far as it can drive, so it's a random test. Say the test coverage by such a random test is we can combine both scenario tests and this random tests. This is the last one. So we combine also insurance program. Sorry, subtitle is written in Japanese. But the whole operation that we do in Japan is monitored by insurance company or by our administration staff, and the vehicle is always connected by 4G or 5G. And when something bad happens, our insurance program partner, it's a major insurance company in Japan, can help to reclaim the vehicle. So it's like a road service or call center, including insurance program. Finally, I think you can get a real kind of public services. So this is what we're doing today. And so we basically do this business in case of, say, Olympic. So we provide both Autoware and Web tool chain to support development and operation of AD technology. And what is we are very good at is to define operational design domain. So this means that in what scenarios you can guarantee that the autonomous vehicle can operate safely. So if you fail to design your domain, then you can never tell that this vehicle is guaranteed to ensure the safety. So the definition of operational design domain is one of the key capability for a commercial company to start a business on autonomous driving. And yeah, based on operational design domain definition, you can now define a reference sensor computer design, then adopt it to the customer's customer's requirement or criteria. Right, so I'll stop here. If you have any question, I'm happy to talk to you. Thanks. Thank you very much.
I have a question. Thank you for the talk. This was really interesting. A lot of the sort of data sets you were showing and the examples you were showing in simulation, it was clear that they were from Japan. And so like driving on the left side of the road and things like that. And I'm wondering how easily transferable everything is to other places in the world.
So from Autoware stack point of view, it doesn't really matter but test scenarios, you have to register your scenarios. So I would say data set, of course, are different. And as far as Tier 4 makes a service in Japan, we need to test, verify and validate the system by using kind of Japan oriented scenarios. While if you register US environment through a Web2 chain, from systems stack point of view, it doesn't really matter. So yes, it can drive in right lane and left and right hand. You can make it done.
Thanks.
Yeah, I have another question. So, so I think the open source aspect of Autoware is a big is a big plus, and I think two major benefits of making it open source. The first one is definitely to allow to assist everyone's many other people's progress on the development of autonomous systems. The other one is to allow everyone else to be able to contribute together to this to this code base. So could you give any example of any like significant contribution to the Autoware that's outside the Autoware Foundation?
Yeah, one is simulator contribution was very appreciated, because even Tier 4 or Autoware Foundation, we focus on AD stack. Like simulator, if it's a scenario based, we can still somewhat deal with that. But say if it's kind of large scale project, say based on Unity, then it's completely out, out of the capability of Autoware Foundation or Tier 4. So it was a very good contribution from LG or Intel. They provided a simulator environment for Oldware. Another good example would be probably say test platform, not say the large scale, but a small scale test platform like Raffle provided us with F110. Even a student can purchase the small robot car, then install Oldware and learn how to use it. Then you can use that skill and experience for the large scale vehicles. So yeah, there are many other examples, but well, right at this moment, what it comes to my mind is one quite recognized contribution outside of the foundation was a simulation and test platform, and of course sensor contribution or computing unit contribution, since Autoware Foundation is a software community, so hardware contributions was also appreciated. But there are many contributions aside. Basically, the whole contributions outside of the scope of autonomous driving software, they're all appreciated from our end.
Got it. Thank you. So there's also a question in chat that asking, has Autoware been used in an autonomous racing environment?
Oh yeah. So the question is, yeah, it goes. It happens right now. So if you go go to say F110 project or Indie Autonomous Challenge project, you can find some information. It's a ROS and Autoware and some other member companies collaborated project. So we are using ROS and Autoware in Indie Autonomous Challenge based on the same simulation environment that just I presented today. Yeah, please go to the internet and search Indie Autonomous Challenge. Then you can find some information. Yeah, it's kind of exciting. Not you know, a commercial service scenarios, but probably most of say young students or you know, those who like the cars may enjoy the racing environment.
I have a question. Yeah. So right, there's just a microphone in the front of.
Okay.
Room. Yeah.
Hi, Professor Kato. I have a question about, is there any like behavior recognition module inside the Autoware? Because sometimes when there's no lane and there's no traffic light, for example, in the very small like residential area, there's only like a stop sign in the intersection, then whether the car should go or not go, it's like in the vague, there's not a clear cut of the right to drive in the road. How is it the Autoware currently predicting this kind of behavior? And also this can be also used for something like if there is a very risky driver in the road, would the system be able to tell like, okay, this car is a risky driver that we should keep away from it?
Okay, the good question. So that's why I said that the planning module in Oldware may need a huge improvement. So today, in the main line of Autoware on the GitHub, it only includes rule-based planning. So you can still define behavior, but it's rule-based. And probably what you're telling is more data-driven behavior planning. So the reason why I'm still in university or tier 4 has a lot of student researchers is that we want to have Autoware as a platform that can be used for both commercial and research and development. So to be honest, in limited environment such as Olympic Athlete Village, probably we don't really need, say, black box data-driven behavior planner. You can define rule-based behavior planners, then test them, say 2 years, 3 years, still work. But if you want to make the AD stack behave as a human driver, now, yes, you have to shift your technology base from rule base to more black box data driven, which yeah, you can find a lot of research projects in academia. I'm quite interested in using cutting edge results from academia. So the question here is, yes, we can still use data-driven behavior planner. And so Autoware, the architecture of Autoware is now its core and universe, and core is maintained by Autoware Foundation. And what you can find today's Autoware repository is a core architecture, while universe is more it's a marketplace, or it's more, commonplace where even students can push their contribution as far as they are verified. So I expect that this kind of universe architecture now we can find more and more cutting edge modules, and one of that examples would include, as I said, kind of data-driven planning module. Say, for instance, Tier 4 already has the one module, and we already use it for our commercialization. But I want to make it also public to Oldware. So the answer to your question is, today, Autoware is based on a rule-based planner. And in most cases, for the commercial projects, basically rule-based planner would work. But if you want to expand operation design domain from just limited place to city-wise place, then yes, you need a black box data-driven planner, which can behave like a human. Today, we don't know how to verify or validate that. Maybe we can also improve test platform, like verification and validation methodology. But once it's established, I think a data-driven planner would be say quite innovative contribution. So which in the core architecture of Autoware may be difficult because there are more practitioners, while universe architecture, which can be used together with the core architecture, can be more, say, cutting edge. So I expect data-driven planners can also merge into Oldware as part of the universe architecture. The details will come next month or so. So we are also changing the architecture. Today it's a monolithic, but I want to make Oldware a micro kernel architecture. So core and universe. And yeah, if you guys interested in cutting edge contribution, it's also appreciated. But today, Autoware is based on a rule-based planner.
Thank you.
Can I ask a question? Yeah. Hi, Professor. I was a little bit curious about how V2X communication would play a role, specifically if we could, minimize onboarding, processing, and help orchestrate roads better. So I was just kind of wondering, in the future, do you see Autoware having updates to implement vehicle-to-vehicle or vehicle-to-infrastructure communication?
Yeah, that's also the same structure to a data-driven behavior planner. So we understand that a V2X, a V2V infrastructure is very helpful, like traffic light recognition. If traffic signal can just send the color information to the vehicle, then that's more reliable and accurate, rather than letting a vehicle recognize the color information. So and V2X, V2X infrastructure, I see a lot of research teams are working around V2X infrastructure based on Autoware. Like what I'm interested in is basically implement Autoware into the infrastructure. Like you can set a intersection computer, which also installed with Autoware, has the same capability of autonomous vehicles. It can detect the cars, it can detect the pedestrians. Then they can share the result of, say, imagine intersection. If your vehicle approach behind some lane, you may not be able to see other cars if there are some buildings. One idea, of course, both cars share information, but if you have some another computer just the center of the intersection, it can recognize the 360 degrees around intersection. So it can also share the result of the perception with other vehicles approaching behind each lane. So there are many ideas, V2X. Also the question here is, what's also the communication protocol? What is the layer 2, layer 3 interfaces? Probably DSRC is, getting more like a kind of mobile cellular, protocol. So I think that once we have more, say, common layer and protocol for V2I, V2V communication, then I think it's getting more and more popular. But today, not only kind of communication methods, but also communication protocols or layer interfaces is quite diverse. Maybe today may still take a while to get them into Oldware, because we have to standardize the communication kind of method or interface or protocol first. But I personally am quite interested in V2X infrastructure, because I know that having only the car recognize everything maybe not realistic to make it work in a kind of public place. So today, as I said, in the limited place without V2X infrastructure, it works. But in the next decade, if autonomous vehicles really go into a kind of public place, then yeah, V2X infrastructure would be one of the major requirements to ensure the safety of the AD solution.
Thank you.
Okay, I'm afraid we are officially at the end of the seminar, and why don't we have last call of any remaining questions from the audience? Okay, and with that, I think we can end this seminar. And thanks again, Professor Kato, for attending the seminar, and thanks for accommodating our differences in the time zones. Yeah, and I think we can all appreciate your work and achievements in the open source autonomous driving technology. And
yeah, thank you very much for your attendance. And if you're interested in open source software, we all encourage you guys to work with us. So if you're interested in, please contact us directly, or Professor Lafu is also a good contact window for us. So I expect more contributions that's from outside of the foundation. So yeah, hope to work with you guys in the future.
All right, thank you, Shinpei.
Thank you. Thank you,
Bye.
guys.
yeah.